All right, let's see how you did. So we're going to go here, and this will be Kansas equals quartile inclusive. I'm going to come over here. I already put this Kansas State University sale amount all the way down. F4 to lock that in. Comma to stop the selection. We do want to pick our minimum of 0 again. And we'll drag this down. Do the same thing. I'm going to copy this. Control C equals average. Control V to drop that in. Equals stdev.s. Control V to drop that in. And then I'm going to take all of this, and I'm going to go to the paintbrush here to format paint that onto Kansas. This is not an error, it just needs to be wider. So there we go. All right, so I went very quick on that, but hopefully if you made a mistake, you can go and see where you made the mistake. All right, so let's look at these numbers a little bit. I compare these two data sets. Interestingly, that we look at our median house price for Kansas State's $162, which actually is not that much higher than the minimum in UMass Boston. Sorry, UMass Amherst. In fact, the maximum house price here of $365 is 75% of the houses in the University of Massachusetts are less than that. Our average is quite a bit lower here too at 170. So one of the interesting things here is these numbers as we look at standard deviation. Because remember, standard deviation is a measure of how far the data spreads out, how tight the data is. So we can see for UMass, standard deviation is about $80,000, which is significantly more than the $58,000 for Kansas. Which means, what does that tell us? It means that the UMass Amherst house prices spread out much more than the Kansas State University ones. It's a much tighter data set. Okay, and so this is how we use these 5 number summaries to kind of look at different data sets and different things going on. So I do have one more thing here. So let's say that we've decided, you know what? University of Massachusetts, that is what we want to do. But we don't like any of the houses there. So what we want to do is we want a 2,000 square foot house. We're going to build one. But I want to know approximately what that cost is going to be. So what am I going to do? Well, we are going to do a simple linear regression. So remember, this is a curve fit. This is going to be based on one variable. So we're going to do a simple linear regression of the house price based on the square footage of the house. And then once we have our equation for the regression, we are going to plug in 2,000 square feet to see what a house should be. So that is your next thing to work on. So at this point, please pause the video. Take about 10 minutes to go and do that regression analysis, and then turn the video back on and we'll check to see how you did. Alright, so I'm assuming that you had paused the video, you'd worked on things, you want to see how to do it. So we have 2 different ways that we can do a simple linear regression. We can do it using the scatter plot, adding a trend line, displaying our equation on the chart, and grabbing the equation from there. Or we can use the data analytics plugin. So that's what I'm going to do. So let's go here. We want to do this for UMass. So let's go back to the University of Massachusetts Amherst. So that's all we're showing. We go here to data. We go to our data analysis plugin kit. And we will go to regression. All right, so it asks us for a couple things. It wants the input, the Y range. So remember, when we're dealing with regression, the Y range is what we are trying to predict. It is the dependent variable. X value, we can put whatever we want. That's the independent variable because that X value drives the Y value. So in this case, we're trying to figure out what the cost of a 2,000 square foot house would be. So that 2,000 square feet is an X variable. So our y variable here, we have to give it data, and so we're going to say the sale amount. Now, be careful, because we are filtering this. You don't want to grab 1, because then you're going to grab all the records between 1 and 6655. All right, and so our X range, well, our X range is going to be the square footage of the house. This is our other little data point that we're plotting. So let's go grab all the square footages of the houses that we have. We do not want to say that we have labels, because we don't, because we're not going all the way to the top. We don't want the constant to be 0. We don't care about confidence level. We do want to give it an output range. And I'm going to go and tell it to just drop it right here. And that should be fine. We don't need any of this. We will say OK. And sometimes this ends up happening. So when I'm going to go down through here, it sometimes does funny stuff. I'm going to just get rid of all of this. I'm just going to let it do a new sheet then. So new worksheet, and say OK. I don't know why it does that sometimes, but it just does. All right, so once again, all these big scary numbers, we only care about 3. Not whatever I just highlighted here. That's not what we care about. Those 3 numbers that we care about are the R squared. Tells us how good our curve fit is. So 41.41. And then our variables. So the intercept, that is the B on our equation. X variable 1, this is the slope of our line. So remember, what is a line? Y equals mx plus b. So y is the sales price of the house. I want to know what that is. I want to know what that is for a 2,000 square foot house. So what I'm going to do is I'm going to take m. That's my slope right there. That coefficient for the x variable is my slope. I'm going to multiply it by 2,000 square feet, because that's the house I want to predict for. And then I'm going to add to that my intercept. And then I'm going to run the equation. So, based on our regression analysis and our regression line, if we had a 2,000 square foot house, we are going to expect it to be $355,000. Now, I do get the question in class. I'm like, well, where did we get 2,000? Remember, we're predicting a 2,000 square foot house. What if, okay, maybe we don't want to get a house that big. Maybe we only want to get a 1,500 square foot house. So why don't we do that? So 1,500 square foot. So based on our regression analysis, a 1,500 square foot house will be $292,000. So once again, with regression, we are talking about doing those lines. Now remember, we don't have to do it with this plugin. We could have gone through and said, okay, here's my sale amount. Let me get, here's the square footage of my home. Insert, come over here to our scatter plot. Input our scatter plot. Now, these axes are not the way that I want them, so let's go and make a couple changes here. So move chart, new sheet. We'll drop that in. Now I want to flip these axes. So, and the thing is, you switch rows and data, you see it kind of messes things up because it doesn't work. Doing that doesn't work really well for the XY scatter. So we're going to go here into select data. We are going to edit, and we're just going to change this around. So we're going to make B and F, and then we'll make F and B. So really just flipping our references around a little bit. And say, okay. And so now we've got our sale prices here. We've got our square footages. I'm going to hit the plus. I'm going to do a trend line. I'm going to go to more options. Display equation, R squared value on the chart. And so there we go. And as you can see here, we'll make this a little bit bigger for TV. We've got all the same stuff that we got from running that plugin. Oops. And so it doesn't really matter how we do either of those. We can run it either way. If we had the proper plugins for Python, we could do that. If we were running this in Tableau, we just right-click, say Add Trend Line, and it would put that in. So any of these ways is going to get us what we want. All right, with that, we are done with this data set. Please upload this for engagement for this class and continue on to the next example.